In California, catastrophe cuts one of America's most vital highways in two.
Once I got on scene, wow, a whole section of the bridge was missing.
In Texas, a mammoth refinery explodes with deadly consequences.
You could see the fireball from almost 20 miles away.
In the UK, scientists launch an interplanetary investigation.
We were just watching for that moment that said Beagle II was landed, and we waited, and it didn't come.
And in West Virginia, tragedy strikes a vast suspension bridge.
It yanked on the other guy tower, and then the whole bridge collapsed into the river.
With big builds, even the smallest mistake can be a huge disaster. From miscalculations to misunderstandings, some with deadly consequences. These catastrophes are every engineer's worst nightmare. With everything they build, engineers must always consider Mother Nature. Underestimate her, and the consequences can be disastrous. Like this catastrophe in California that shut down a major freeway.
There was over 10,000 people just stranded here. I had never seen anything like that in my entire life.
A desert bridge with a potentially deadly weakness.
I could see a whole section of the bridge was missing, and I could see just the tail end of a pickup truck sticking up.
This is a major highway. It's just so lucky that no one was killed.
America. This vast country depends on a nearly 80,000-kilometer-long highway system. And key to keeping the southern half of the nation moving is Interstate 10.
At around 2,500 miles, I-10 is the fourth longest interstate in the U.S. and connects LA on the Pacific coast with Phoenix, Houston, New Orleans, across to Jacksonville, Florida.
Former firefighter Alex Gregg lives near the I-10 in Southern California.
The I10 Corridor is very vital for travelers as well as for commerce. All goods pass through here on their way either to or from Los Angeles, from the harbors out, or to the harbors going other places. So it's an important link from Los Angeles to all points east.
From here, I-10 runs east, across the Sonoran Desert.
We're in the middle of the desert. This is not what people normally think of when they think of California, but we have a lot of this desert area down in Southern California between Los Angeles and Phoenix.
The road stretches endlessly across flat, dusty ground, but it's also riddled with gullies created by sudden rains.
We live in a very arid terrain. Doesn't look like we get much rain here, but surprisingly, in the summertime, we get what we call monsoon storms that create flash floods.
As I-10 grew, dozens of bridges were needed to cross the gullies, like these across the so-called Tex Wash. Bridge engineering expert Dr. Abul Hassan Astane-Assel explains the name.
It is a Tex Wash Bridge. Tex Wash means this is a place that water created by washing a path. There is no river here. It's just a place that flood comes, very flash floods, very heavy flood suddenly, and washes this path.
With so many washes to cross, the state settled on a standard formula for bridges.
In California, they were using a lot of concrete to do these things, and they ended up having standard designs for small bridges. So they had this 20-meter long spans, and they would just try to use it many times.
Tex Wash was originally too wide for the standard span, but rather than design special longer bridges, it was simpler to fill in the sides of the wash, making it narrower so the shorter spans would work.
Completed in 1967, the Tex Wash bridges safely carried I-10 for almost 5 decades. But in 2015, a storm was brewing. July 19th, almost 18 centimeters of rain fell on the Chuckwalla Mountains to the south of I-10.
Because of the terrain the way it is, the water doesn't absorb quickly, so it runs downhill rather quickly and becomes a flash flood. It can become a very dangerous situation for people. And the flash flood will be here before you know it, and it's gone before you know it.
A firefighter at the time, Alex Gregg, was on call at nearby Desert Center.
I was on duty that day, and I was covering battalion chief, so I got called out to a bridge collapse on Interstate 10 just west of Desert Center.
Traffic was already beginning to back up.
Once I got to just past Schuylkill Summit, the traffic really came to a standstill and everybody was stopped. Because the traffic was backed up that far, I knew we had a serious situation on our hands.
Victor Garcia's family runs the only rest stop on this remote stretch of I-10.
I had never seen anything like that in my entire life. There was easily over 10,000 people just stranded here.
Alex and his team of firefighters made it through the chaos.
I could see a whole section of the bridge was missing, and I could see just the tail end of a pickup truck sticking up, knowing that there was a truck stuck down in there and people were trapped inside. I knew time was of the essence.
The race was on to rescue the driver of the pickup.
We got a rope system put together, and then I put my trained firefighters on it. He was pinned in the vehicle, so we had to use our extrication tools, also known as the jaws of life, to go down there and pry the truck open in order to get him out. Once we got him out, he was extremely relieved, especially once we got him back up on top, away from the fallen bridge.
With the bridge down, traffic was going nowhere.
It was still raining that night, so it was mass hysteria. We were getting overwhelmed. We ran out of everything. We ran out of food, ran out of gas, ran out of everything.
Authorities set up diversions, and by dawn, both the traffic and the rain were gone as quickly as they had come.
The next morning, it was dead. Nothing. The freeway was shut down. No one was passing through. You could hear, crickets.
After the storm passed, everyone wanted to know what had caused this catastrophic failure. Abul Hassan was called in to investigate exactly what went wrong. On the surface, it was simple.
What happened that day for Tex Wash Bridge was because of this unusual flood, which experts actually rated it as 1,000-year return flood.
Any structure would struggle in the face of a 1,000-year flood. But here, narrowing the gully so the standard bridge length would fit had made things worse.
When the wash was narrowed, the shape was altered too, so water had to change direction not once, but twice to flow under the bridge. First as it hit the roadway, then again to curve under the bridge.
You have to realize the pressure of water that's coming down. Try to tell water that when you get to this road, I-10, it's important, please turn right. That cannot be done in engineering. You tell the flood, when you get here, please turn left, because my bridge is there. Wow, I can't turn left because it's too small for me. Whole volume of water coming. The water, it gets a lot of turbulence and the velocity goes up.
The turbulent, fast-flowing water eroded the bridge foundations on the outside of the bend. It's what's known as scour, and that end of the bridge dropped into the wash.
And yet, it turned out, reshaping the wash wasn't the only mistake made here. As Professor Astane Assel discovered, the foundations were missing a crucial element: piles.
So if this is pile and foundation is on it, if the soil under the foundation is washed, the pile will still be there. But in this case, they didn't put the piles under the foundation. So the water came and washed the soil, my hand is foundation, and it just dropped.
And there was one final fail that channeled the water straight into the foundations: the so-called wing walls, which were at the wrong angle.
Wing walls in bridges are the walls that you put at the end of bridge and beginning of bridge. They're usually parallel to the path of water, so the water passes by them like a wall, so it doesn't hurt the foundation. In this case, the wing walls were here. What good it's gonna do, other than when the flood comes, hits the wing wall actually and washes the bridge. So these two fingers as a wing wall don't do any good for flood. They should be here, like this. So the flood goes through here.
By narrowing and redirecting the wash, engineers created the perfect storm for scour. Combined with weak foundations and misplaced wing walls, this bridge didn't stand a chance against the epic flood.
We're extremely fortunate that we didn't have more cars fall into that opening other than just the one, and everybody else was managed to stop. It could have been a whole lot worse.
With I10 out of action, drivers were forced to take long detours. A new bridge was needed and fast.
Time of the essence of getting the freeway open, there was no way that we were going to reopen the freeway anytime soon because the bridge was totally destroyed and had to be completely rebuilt.
The $5 million rebuild took 2 months, but finally the bridge reopened, complete with heavily protected foundations, connecting California and Arizona once more.
This failure is a reminder of the challenges engineers face every day working against Mother Nature. If it wasn't for that 1,000-year flood, who knows how long that bridge might have lasted.
I came away with a better appreciation for the movement of water. Even in the desert, you just never know when Mother Nature might get you.
When it comes to big engineering, checking every detail is crucial, no matter how small. Because if just one thing goes wrong, the results can be catastrophic. Like this disaster in Texas that rocked an industry to its core.
The 911 lines were being swamped with anxious calls.
A refinery explosion that was felt more than 20 kilometers away.
A seismic event that registered 3.5 on the Richter scale.
Changes had to be made to keep this from ever happening again.
It has the power of 2.5 tons of dynamite.
Houston, Texas, a thriving metropolis thanks to one industry: oil. Massive industrial complexes run along the banks of the Houston Ship Channel, which flows into Galveston Bay and the Gulf of Mexico. Local journalist TJ Olds knows the area well.
So the Galveston Bay region is so important to the oil industry for all of America when it comes to the oil refining and chemical processing that happens here. It is massive.
The 10 major refineries in the region process more than 2.5 million barrels of crude oil per day. And it's turned into more than just gasoline.
So a lot of people consider oil as, oh, that's just fuel for our car. That's not true. It's a lot more than that, particularly is in every plastic product you have out there. So it's part of our lives. It's in your homes, it's in your cars, it's in your office, it's everywhere.
This 260-hectare complex has been at the heart of the industry for decades, producing one of the most widely used plastics today, polyethylene, found in everything from packaging to surfboards. Kenneth Block is a process safety supervisor.
In the late 80s, this particular plant that we're standing in front of provided approximately 1/3 of the global supply for high-density polyethylene.
When we think of plastic, we picture a clean, stable solid. But the raw ingredients started life in a seething mass of natural gas and crude oil.
Refineries take crude oil and begin by heating that crude oil up, separating it into different components. These processes contain a mixture of flammable substances that, if released into the atmosphere, can cause an explosion and fire.
The volatile components are processed inside 45-meter tall towers, where the liquids flow through vast oblong loops of pipe, known as loop reactors. Flammable ethylene gas is fed into the reactor and dissolved in a cocktail, including isobutane, hydrogen, and hexane, which are also highly flammable.
The mixture spins around the loop where it's massively compressed at 40 times atmospheric pressure, forcing the ethylene molecules to join together or polymerize into polyethylene.
The solid polyethylene particles pass out of the reactor into 6 vertical tubes called settling legs, before collecting in a flash tank below. Over time, the legs become blocked, requiring regular maintenance.
The material coming out of the reactor, polyethylene particles, fluff is what they call it, this would tend to accumulate inside the settling leg and form a large cylindrical plug, essentially choking off flow. So that plug would then have to be removed, or else it would interrupt production.
Like any production process, keeping things running smoothly is crucial. That's easier said than done when you're dealing with highly pressurized, explosive chemicals.
October the 22nd, 1989. 3 of the 6 settling legs on one of the loop reactors had become clogged. With the reactor still running, the 3 blocked legs were shut off using 20-centimeter ball valves located at the top.
The loop was still full of a swirling whirlwind of flammable chemicals, so properly sealing the legs for cleaning was absolutely crucial.
The first leg was successfully unplugged and reconnected. The following morning, while working on the second, disaster struck. A massive explosion rocked the plant.
You could see the fireball from almost 20 miles away. It has the power of 2.5 tons of dynamite.
The force of the blast was unprecedented.
I do remember my parents telling me that at the time of the explosion, they felt the earth move, and that was between 10 and 15 miles away from where we're standing here.
We had debris that was found several miles away from the center of the blast. So that just tells you how powerful this was.
The shockwave shook the community.
It created a seismic event that registered 3.5 on the Richter scale.
Fires raged for nearly 10 hours before emergency crews were able to bring them under control.
Where we're looking at right now, this area in the background was just a form of blackened, twisted metal.
Among the devastation and wreckage, over 300 people were injured. Sadly, 23 more lost their lives. With similar facilities around the country still in full operation, authorities immediately began looking for the cause of the explosion.
Investigators knew the blast happened when the settling legs were being cleaned, so the most likely cause was an unintentional release of flammable gas.
The accident involved the release of 85,000 pounds of a flammable hydrocarbon mixture at the bottom of the reactor, and this formed a vapor cloud, which then contacted an ignition source about 90 seconds later.
The big question was, why had the gas escaped from the reactor? Investigators found that the problem stemmed from inside one of the settling legs, with a 20-centimeter ball valve intended to control supply.
In normal operations, these ball valves are open and closed from the control room with compressed air, but the pneumatic system can be overridden using a manual lock on the valve.
Following protocol, before removing the legs for cleaning, the lock was activated.
The block valve was closed. The air actuator hoses that would be used to open and close the valve were removed, and then the valve was physically locked into position.
But there was a problem when the hoses were reattached.
The biggest mistake that happened here was hoses. Now, they had been taken off for safety precautions when the maintenance was being done. When they were reconnected backwards.
Connecting the air hoses incorrectly proved to be a fatal error.
There was nothing to stop these 2 hoses from being reconnected the wrong way round, and no way to know that anything was wrong before the system came back online.
Tests done after the investigation determined that this particular valve design could be worked in reverse, and that making the mistake of fastening the air supply line to the discharge actuator side would actually force the valve open instead of closed, even though the switch was in the closed position.
Although the reactor's control unit registered that the ball valve was securely closed, it was actually open.
A valve that was needed to be closed during maintenance was inadvertently open and released the entire contents of the reactor in a matter of seconds.
Vapor was released, highly volatile vapor. And that was the beginning of the problems, because as that comes out, it gets ignited, then you have a massive explosion.
While it was too late to stop this devastating tragedy, changes were made to prevent a disaster like this from ever happening again.
The events that occurred here on October 23, 1989, accelerated the development and implementation of process safety standards, things like designing couplings that will only connect one way.
So any facility you go in nowadays, you'll see the sign that says so many days since the last injury. That's because the standards are there. They're being followed in many ways. Safety is a priority.
Handling massive amounts of volatile chemicals will always be dangerous. But it's crucial that after an accident like this, new safety systems are put in place to reduce the risk in the future.
When epic engineering goes wrong, the problem can be clear as day. But sometimes we're left completely in the dark. Like this Vanishing Act that was out of this world.
The descent to Mars, the 7 minutes of terror, people's careers are on the line.
When the engineers hadn't first heard back from the lander, we just didn't know what had happened.
A true engineering enigma.
This sparked a decade-long interplanetary mystery.
What's out there? And are we alone? Questions that have long gripped the human race. Astronomers like Hannah Banyard from the UK's Royal Observatory are helping to find the answers.
Astronomy in general is really important, not only to the astronomers and the scientific community, but the wider public, because it helps us understand our own place, not only in the universe, but on Earth.
One planet more than any other has long been in the spotlight: Mars. Dan Kendall from the UK National Space Centre explains why.
Mars is a very barren planet, but we know enough about it and we've studied it enough to know that in the past there may have been water on Mars. It might have had a thicker atmosphere.
We know that it had lakes of liquid water, it had oceans of water, and water is one of the key signs of life. So when we're looking for life on another planet, Mars is really where we want to go to.
The problem is getting there.
Mars can be 400 million kilometers from Earth, but astronomers calculated that in 2003, the planets would be less than 60 million kilometers apart.
The European Space Agency realised that there was going to be this moment where Mars and Earth were closer together than they had been for more than 60,000 years. So they came up with the idea of the Mars Express mission.
Mars Express was designed to map the planet's surface from orbit. But British astronomers saw an opportunity to add an extra piece of hardware that could land on the Martian surface.
A team of academics got together and started thinking about whether maybe a British lander could be included on that mission as well, to take that chance to investigate the surface of Mars and look for the biosignatures of life.
That's how Beagle II was conceived.
HMS Beagle was what took Charles Darwin around the world in the 1830s and led to the origin of species. He learned so much about life on Earth, and the name Beagle II is all about the fact that this mission was intended to tell us so much more about life on another planet.
In the 70s, NASA sent 2 Viking landers to Mars. They found tantalising clues that there might once have been life there. Beagle II was far more advanced, and the team hoped that if there was life on Mars, Beagle II would sniff it out.
One major challenge was finding room for the Beagle within the existing Mars Express orbiter. It would have to be both small and lightweight.
Beagle II was about the size of a bicycle wheel and it looked like a barbecue, but it was loaded with scientific power.
In front of me, we have a model of Beagle II. When it landed, it would open up like a pocket watch, and then these solar panels would each in turn open up to make it larger. So they packed a huge amount into an incredibly small space.
Base camp for mission control was located here at the UK's National Space Centre. Chief Executive Chas Bishop explains.
The idea came about to put the Lander Operations Control Centre in front of the public. They were getting access that probably hadn't been granted before. So, you know, there was a little bit of a risk there that, you were seeing a space mission, warts and all.
On June 2nd, 2003, Mars Express with Beagle II on board launched from the Baikonur Cosmodrome in Kazakhstan.
I can remember the launch very clearly because a launch really does make the hairs stand up on the back of your neck because it is risky and people's careers are on the line.
Liftoff was a success, but there was a long way to go.
The journey to Mars is 7 months. The calculations involved in just reaching orbit are staggering, let alone getting the lander through the atmosphere to a safe touchdown.
Just before Christmas 2003, Mars Express made it successfully into orbit, and Beagle II began its perilous descent, right on schedule.
The descent to Mars, the 7 minutes of terror, as it's been called consistently with Martian missions, that's when it enters Martian atmosphere, to get down to the surface is exceptionally difficult.
The atmosphere on Mars is about 100 times thinner than on Earth. The plan was for parachutes to slow it down before a cocoon of airbags inflated in the hope of a soft landing.
Any number of things could go wrong, burning up in the atmosphere, not quite getting the trajectory right, missing your landing area. But it's only when you get to Mars that you find out whether or not it's going to be successful.
Beagle's command team waited anxiously for the first communication from the Red Planet.
We were watching expressions, and every now and again we'd get a briefing, but we were just watching for that moment where you see the expressions that said Beagle II was landed. And we waited, and it didn't come.
With nothing but radio silence, Beagle's fate was a mystery.
When the engineers hadn't first heard back from the lander, the scientists knew that perhaps there was just a minor problem that could have been solved. But then 2 months later, when it was declared lost, there was definitely a sense of disappointment because we just didn't know what had happened.
Well, I can remember at the time there's a lot of speculation as to what might have gone wrong. All of the speculation assumed that that descent and landing has in some way failed.
Roughly half the missions to Mars have failed, so Beagle II wasn't the first. But with the evidence lost and silent, the team was left guessing as to what had happened.
Perhaps the parachute hadn't deployed correctly. That obviously could have been catastrophic for the mission. Maybe there was a fault with the heat shield that meant that the whole package might have burnt up on entry into the Martian atmosphere. Or, of course, landing at quite a high speed, relying on these gas bags to protect the lander. It would only take the gas bags not to inflate correctly or the landing itself to be heavier than perhaps expected.
Beagle II's fate remained a mystery for more than a decade.
Between 2003 and 2015, sadly, Beagle II was very much seen as something that had been a good attempt but had ultimately failed. But then something happened in 2015 that changed the narrative completely.
NASA spotted something mysterious on the Red Planet.
I got a call. Chas, hot news. We might have some images of Beagle II on the Martian surface. And they showed us the long shot, and we squinted and thought, could it be? It's a bit of a dot, difficult to see, and closer in. And you thought, actually, maybe. Then there was the final shot, and there it was, with that clear disc in the middle. and the solar panels. And it was at that point they said, that is Beagle II, it's landed.
So when Beagle II was discovered, it meant a lot for the British scientific community and the Beagle II team, because it meant that their plans for how they landed the spacecraft were successful.
Beagle II had landed, but why did it fail to phone home? Scientists pored over the images of the landing site.
Further study and more photographs, the scientists determined that only 2 or possibly 3 of the 4 solar panels on the spacecraft had opened up. The ones that didn't, however, blocked the communications antenna. So that's why we could never receive a signal from the lander. But that doesn't mean that it didn't actually function.
It might have done something. It might have done something brilliant. But with that antenna trapped, we will never know. Now, how frustrating is that?
The question remains, why didn't the other panels deploy? And was that all that stood between success and failure?
It's possible that malfunctioning airbags and parachutes led to a bumpy landing, damaging Beagle's solar panels and antennae, meaning that Beagle could never phone home.
So some scientists think that the lander had actually started to perform some of the science experiments because there was an auto mode, essentially, that if the lander didn't hear any instructions, that it should begin doing the experiments it was programmed to perform. And so if it did do that, that data will be still recorded on the craft, which could be retrieved in a later mission.
How close was that mission to being entirely successful? 1 solar panel. And who knows, it might be a speck of dust. It might be something so trivial that kept that final panel furled. And we won't know, unless we go. And who knows, we might one day, something or someone might go and take a look and say, oh look, now we know. But until then, we won't know.
Beagle II didn't complete its mission, but key lessons were learned.
We've certainly shown that it landed, the parachute worked, the gas bags worked, everything worked. It had even started deploying itself. It's incredibly difficult to get to Mars and succeed, but for the final section, not quite to work, perhaps because of a harder landing than they expected. Who knows? We don't know at this stage, but it was a really incredible achievement to put a UK lander on the surface of Mars.
And whatever Beagle's fate, its technology has contributed to future Mars missions.
One of the instruments on Beagle II, the mole, was actually used as the inspiration for NASA's InSight lander, which is on Mars now. That's got a similar tool on it, which is used to dig up to 1.5 meters underground to help measure the thermal properties of the planet.
So Beagle II certainly wasn't a waste or a complete failure in so much as certainly things were learned, lessons were learned about how things were done and things that could be improved upon in the future for missions back to Mars, but other missions around the solar system.
Today, our quest for answers on Mars continues, with NASA's state-of-the-art Perseverance rover now leading the charge.
Perseverance is a hugely exciting moment in Mars exploration. It's got an arsenal of sensors to look for signs of life and to establish if humans really could one day colonize the red planet. And with the tiny helicopter Ingenuity, we've seen the first powered controlled flight on another planet. Incredible.
When it comes to engineering, every component, no matter how big or small, is vital to success. Even a tiny fault can cause a major disaster. Like this catastrophe in West Virginia, a fatal collapse on a vital river crossing.
It was just a shock, a total shock. Nobody expected that bridge to fall.
A tiny flaw on a massive structure that triggered one of the worst bridge disasters in US history.
The fact that a bridge of that magnitude was able to collapse in less than a minute is staggering.
And a tragedy that forced a nationwide change in safety regulations.
It affected everybody. It's just something you just won't forget, the tragedies that happened that day.
The mighty Ohio River runs nearly 1,600 kilometers across America. A constantly moving border that divides the Midwest from the South.
The Ohio River flows through 6 states, and it's the source of drinking water for more than 5 million people. It also transports more than 230 million tons of cargo every year.
For centuries, the river has been a vital source of life for small towns that have sprung up along its banks. None more so than Point Pleasant in West Virginia. Journalist Jim Ross knows the town well.
This is beautiful downtown Point Pleasant, West Virginia, one of the oldest communities in this part of the Ohio Valley. This town is really built around the river. Historically, this has been an area that has built boats. It has serviced boats. It still does. Its identity is tied to the river and it's tied to its history.
And Point Pleasant has always had strong ties with its neighbors on the other side of the water.
It is very much connected with the neighboring communities over in Ohio, Gallipolis in particular. People cross the river to shop, they cross the river to work. Although they're in 2 different states, West Virginia and Ohio, people here tend to think of themselves as being one community.
Till nearly 100 years ago, this old railroad was the only crossing bridging that gap. So in 1927, work began on a solution to connect the 2 communities by road, with the Silver Bridge.
The Silver Bridge took its name from its metallic aluminum paint, but that wasn't the only thing that made this crossing stand out.
Opening to traffic on Memorial Day 1928, this 2-lane crossing was no conventional suspension bridge. Professor of Engineering Gregory Michelson explains.
The way a suspension bridge works is the roadway is supported by a series of suspension cables that cross 2 guy towers on either side of the river.
With most suspension bridges, the main cables are made of thousands of narrow wires, bundled into strands, all working as one giant cable. But the Silver Bridge was different.
What made this bridge unique was instead of suspension cables, a series of I-bars were used as the main supporting elements. So an I-bar is basically a flat bar of steel with 2 holes drilled at the ends.
The giant bridge swapped suspension cables for a series of I-bars, working like 2 bicycle chains stretched across the river. 2 I-bars were paired to create each link, while smaller bars supported the road below, all secured with vast steel pins through the eyes. For nearly 40 years, the Silver Bridge carried up to 4,000 vehicles a day. But the crossing that brought the communities closer together would very nearly tear them apart. Friday, December the 15th, 1967, West Virginia schoolteacher Peggy Huber was heading for the Silver Bridge, making her way home to Gallipolis, Ohio.
Traffic that day was extremely heavy. A lot of people were Christmas shopping, and 2 semis went by and waved to me in the car.
Shortly before 5 p.m., with rush hour traffic backing up, Peggy was stuck, unable to merge.
The bridge was completely full of traffic, and I was upset that the semi-truck drivers wouldn't let me in line. And we got caught at the light going on to the bridge.
But those truck drivers may have saved Peggy's life. At approximately 5 p.m., the 4-decade-old bridge dramatically failed.
I heard this terribly loud noise, and when I looked up, the bridge was falling.
The entire suspended section of the bridge was completely destroyed in less than a minute.
It was full of cars and people, and it just looked like Tinker Toys falling right into the river.
Of the 37 vehicles on the crossing, 31 went down when the bridge collapsed. The 2 trucks were among them. Local journalist Jim Ross was just a child when he saw the devastation.
It was really eerie seeing a couple of piers out in the water, no bridge on them, a roadway with a double yellow line going straight down into the water. looking at where the bridge used to be, it was unlike anything we'd seen, and we hoped unlike anything we would ever see again.
Peggy realized how close to disaster she had come.
Really just that stoplight. My goodness, why was I stopped and not on that bridge? It does make you think about your life different. It was just lucky.
But not everyone was as lucky as Peggy. Of the 64 people who went down with the bridge, tragically, 46 lost their lives. This was one of the worst bridge disasters in US history and sent shockwaves across the nation straight to the White House.
This was so huge that the president, Lyndon B. Johnson, assembled a bridge safety task force to mount an investigation.
In the wreckage found on the Ohio side of the bridge, investigators located their first clue, a broken I-bar.
This massive I-bar would have been about 30 meters above the water. When it cracked, it was the same as if the main cable on a conventional bridge had failed.
When this single link snapped, the whole bridge lost balance. Professor of Engineering Gregory Michelson explains.
It started with that I-bar collapsing, which led to that span sort of tilting over a bit. And then once that span tilted over a bit, it yanked on the other guide tower, and then the whole bridge collapsed into the river.
The catastrophic collapse revealed a weakness in the bridge's original design.
There's no doubt the Silver Bridge was a unique and innovative design, but it was also what's known as fracture critical.
Meaning that if one single part fails, the entire structure can collapse.
While the Silver Bridge used a pair of I-bars to create each link, other similar bridges had multiple plates joined together for additional strength.
So the idea of having multiple I-bars in parallel is that you're not applying the load to one member, you're applying the load to multiple members at the same time. So if one of those I-bars sees failure or sees cracking or sees corrosion, there are other I-bars to pick up the slack.
But with the Silver Bridge, when one of the two I-bars cracked, the other didn't stand a chance.
If that bridge utilized multiple parallel I-bars, for example, the bridge would probably still be standing today.
With the bridge loaded with traffic, and after 39 years of wear and tear, that one small link in the chain brought the entire bridge down, like a house of cards.
That explained the sudden collapse, but not what had caused the I-bar to fail in the first place.
Investigators examined the broken ends of the I-bar and found evidence of a tiny flaw from the original casting process. Hidden out of sight, it had gone unnoticed for years.
Lying undetected, covered by the pin's head, the crack was slowly corroding, getting weaker, through a phenomenon known as fatigue.
When you take that corrosion and you add the phenomenon of fatigue, those cracks grow and then they propagate. On top of that, the bridge was designed in the earlier part of the century. Well, fast forward a few decades, and we see a lot more vehicular traffic, a lot more semis on the road. So all of those led to a perfect storm which caused the collapse.
After the tragedy, a new crossing around 600 meters long was built just over 2 kilometers south. This time constructed as a conventional steel through-truss design and named the Silver Memorial Bridge.
This bridge opened to traffic on December 15, 1969, 2 years to the day after the Silver Bridge fell.
As a direct result of the disaster, Congress passed new legislation to ensure regular inspections of all of America's more than 500,000 aging bridges.
It came at a terrible cost, but the disaster did force us as a nation to think about this part of our infrastructure whose safety had really been neglected.
A mural serves as a reminder of the tragic event that took place that fateful December day.
It was really traumatic, and I mean, even to this day, you know, I have to think when I'm crossing a bridge. It's just something you just won't forget, the tragedy that happened that day.